Hello and welcome to another video. In this video we're going to be working on make two arrays equal by reversing subarrays. And in this one you have a target and an array, and in one step you can select any non-empty subarray of array and reverse it. You're allowed to make any number of steps. Return true if you can make them equal. So they show you how to do it here. But basically, if you can take any part of an array and reverse it, the thing that you want to be able to figure out, is that as long as the numbers are the same in both arrays, you're always going to be able to turn one into the other, because you can just there's always some way to reverse it to do that. So basically, you're just asked, are the numbers in here the same as the numbers in here? The order might be different, but is that the case? So in this case, yes. In this case, yes. In this case, no. So let's just look at a quick example of that. So let's just say we have an array like this, and when one we have 1, 2, 3, 4, 5, and in another we have some random order 4, 1, 5, 2, or like this. Okay, so essentially our goal is to turn the top one into the bottom one, and so basically you can say okay, well, the 4 needs to be over here, so maybe I'll do something like swap the 4 and the 1, and then the 1 needs to be, actually this whole thing would be reversed, right? So, yeah, not an empty subarray. So maybe in the beginning, you just put the 4 here, and then the 1, and then this gets swapped. Then the 1 needs to be here, so you could swap this. So it'd be like this. Then the 3 needs to, or the 5 needs to be here, so you could swap like this, and there you go. So you can basically just keep reversing chunks of a subarray to make them equal. And so now the question is basically, given two arrays that that might not be in the same order, how do I check if all the elements are the same? And there's 3 ways to do it. So one way is a hash map. Pretty simple. You just take all the you just do a count of all these elements, and then you make sure all the keys are the same. And you can actually do this in one hash map. So the way to do this in one hash map, let's say your numbers are 1, 2, 3, 4, 5 in some random order. Let's say one of them has 1, 2, 3, 4, 5, and one has 5, 2, 4, 3, 1. What you can do is you can just go through the indices of all of these. You can do you can do the first one or the second one, or the same time, or whatever you want. But basically what you'll get is you have 1, 1, you have 1, 2, you have 1, 3, you have 1, 4, and 1, 5. And in the second array, whenever you see a number, you just subtract. So then you'll have 0, 0, 0, 0, 0. And then you just check, you go through your values and you check that they're all 0. And if there's one number in one and not in the other, then one of these is going to be 1, and one of these would be -1. So let's say this had a 6. And this had an 8. So your value of 6 will be 1. And your value of 8 will be -1. So you can do this in one hash map, or in an array, and we'll do it in an array. The other one is just sort, and then just compare at every index. So we can just sort, compare at every index, and it should be exactly the same. And then the third one is string hashing. So in string hashing, the basic idea is you can turn a string into a number using some kind of algorithm. And so one common one is take the ASCII value, let's say we have a string like this. And you can basically do the same thing with an array or whatever. So let's say our string is like this as a string. So a really common string hashing algorithm is just take the ASCII value of the character times some big prime number typically. So some big prime number to the power of the index. So this will be 0, 1, 2, 3, 4, 5. And you will get for the first number you'll get 0, for the second number you'll get 1. And you basically add all these together. So ASCII, the first character is this, plus this, and all the way down to the end. And then these are going to be really big, so you can just mod them by some big prime number. Usually use a 10 to the 9 plus 7. So this is kind of complicated, but essentially you can look into it. And you can basically do the same thing with an array. Now, we don't really care about the index. So instead of doing the ASCII value of the index times a prime number to the index, we can just do that, or we don't need an ASCII value. We can just do the number times a prime number to the number. And you can even get rid of this. I tested it. Like even something as simple as this works. And the basic idea of string or just hashing in general is if your algorithm is too weak, then you're going to get a false positive. So two arrays that aren't equal will map to the same thing. Like for example, let's say our string hashing is as simple as just like add all the numbers. Well, that's definitely going to fail because like this would map to the same thing as this. So you basically just need an algorithm that's, you know, difficult enough where you don't get false positives. And that one I showed you does work. So string hashing also works, but string hashing, at least the one that I did there, you need to do the power of every number. And so if you do like even a small number, like if you do 3 to the like 1000 or something, basically this ends up being, this is time complexity of log of the power. So then you're going to get n log n anyway because each number is like up to 1000 and you have to do a power. Or you could pre-compute powers from 1 to 1000, which would be linear, but then you're pre-computing powers, so then you're getting the same problem of the O of n space. Okay, so those are the three: string hashing, sorting, or a count. So let's just do a count in our solution, and we'll use an array, because I was saying before, you don't really want to use some hash maps. So even though an array is bigger, we're going to have some stuff that we don't need. It doesn't really matter. So because we can have numbers from 1 to 1000, let's just make an int array counts that you can do you can make it smaller if you want. The way to make it smaller or bigger is you can figure out like what's the biggest number in these, and then you can make it that big. But I'll just make it 1000. So new int array, and we'll make it 1001. So 0 through 1000. I think you can have 0, right? Let's see. Not 1 to 1000, so I guess we can make it 1000. Okay. And then yeah, then basically for every number in target, we'll increase the count. For every number in array, we'll decrease the count. And then we'll just see every single number has to be a 0 at the end. So for int num in target. And so the index, because I guess to make it simple, I'll just do this. Yeah. 1001. Yeah. Okay. That way we don't have to like change a 0 index into a 1 index or whatever. So this will be easier. Okay. So we can just say counts num plus plus, and same thing in the array. And then we basically just have to look through every single count in the counts, and they all have to be 0. So for int num in counts, if counts num does not equal 0, return false. Otherwise, return true. So pretty simple ways. String hashing is used in harder problems, counts is used in harder problems, and sorting is used in harder problems. So good to know all of them, I guess. This is actually just this. Okay. Okay, so the space for this one and time is pretty easy. So this is just linear and linear. Or you can have n log n with a sorting or the string hashing. Not gonna do string hashing, like I just wanted to kind of let you guys know it's there if you do want to look at it. Not gonna do that for easy problems. So yeah, it's gonna be all for this one. If you did like this one, please like it and subscribe to the channel, and I'll see you in the next one. Thanks for watching.